Okay, so graph on a number line. So I'm supposed to take that and graph it on a number line. Let me make it a little bigger here. So it says T has that symbol with the -2. So we're supposed to say which of those number lines is the correct representation of that statement. Well, let me give you the plan for today for our 4 hours together. Today, the plan, we're going to cover 3.5 and 3.6, and those will both be due as homework tomorrow, Friday at 7 a.m. And then tomorrow, the plan for tomorrow on Friday is we're gonna cover 3.7 and then take practice exam already. Practice exam number 3. Isn't it crazy how fast we're moving? I just gave you back exam number 2. And tomorrow, we take practice exam number 3.
So our next exam is on Monday.
It is on Monday, yeah.
Then we have another one on Friday.
Yeah, next week's a double exam week, and so is the week after. Yeah.
Is the week after our final?
Yeah, that's the second one. The week after we have exam 5 and the final.
Wow, okay.
That's right. Boom, boom. Yeah, in fact, we end the week with those 2, Thursday, Friday. Exam 5 and the final. Yes, this is a wild ride. Are you hanging on with this ride?
Is 201 like this too?
Oh yeah, these summer courses, especially 4-week. 4-week is crazy.
201 6 weeks though.
Yeah, so it's a little more spread out.
All right.
Little more, but still pretty fast. All right, because normal semester, is 18 weeks, right? So the 6-week is triple speed, right? Because you're doing 18 weeks in 6 weeks. That's 3 times compressed. So this is more than triple speed, right? All right. T. Now, what does that say? Does that say greater or less?
Greater. It's greater.
Yeah. Is everybody comfortable? That's correct. Yeah. The symbol. He has a wide mouth side. The wide side is where the bigger item is, huh? So see how this side is wide mouth and this side is narrow. See that? Wide and narrow sides of that symbol. So the wide mouth side is the bigger thing. You always put the bigger thing on the wide side, the smaller item on the narrow side. That's what you're saying with that symbol. So if I went 2 like that, I'm putting the 3 on the wide mouth side. There's 2 ways you can say that. You can either say 2 is less than 3 or 3 is bigger than 2. It's the same truth either way you say it, huh? So, and I could turn it around and then the symbol would go that way, huh? So the wide side is always for the bigger item, and the narrow side is always for the smaller item. So when they give me this, what are they saying about the T? They put it on the wide side, so it's the bigger, huh? Now, on a number line, if I put like -2 here, which side of the number line has the bigger? Because we know this is bigger, right? T greater. Yeah, where's the bigger numbers? To the right. Always to the right is the bigger numbers. To the left is the negative numbers, huh? And so those are smaller. Yeah, to the right is the bigger stuff, to the left is the smaller stuff. So basically they're saying, hey, everything to the right of the -2. That's what this is basically saying. T is the stuff to the right, the greater stuff than -2. You're always shading the letter. So when I do this shading, that's where T is. T represents the shading, or the shading represents T. So, all right, so which one of those has shading to the right of -2? Well, a couple of them do, actually, huh? Looks like answer A and B, these first 2, both have shading to the right. C and D are wrong. They're going the wrong direction. Now, the only difference between answers A and answer B is whether that little dot is an open dot or like a solid dot. So, which of those is correct?
Well, if it's an open dot,
Uh-huh.
that means it's greater, but solid dot means equal to as well.
Yeah, do you know the difference between, yeah, exactly right, greater than or equal to, right? Because if they put the bar on the bottom, that's the bottom of like an equal sign. So what that is, it's the bottom of an equal sign. So you're saying greater than or equal to, right? So if I say, I have got in my pocket greater than or equal to 3 coins. What does that mean? Greater or equal. I could have 3 or more, 4, 5, 6, something like that, right? Whereas if I just say, no, I got greater than 3 coins, more than, I wouldn't say greater, it'd be weird, huh? But more than 3 coins, then I can't have 3. I've got to have 4 or more, really, huh? So that's the difference, right? If they say greater or equal, you could be right on it. If they don't say the equal, you got to be bigger, huh? So that's the difference between these two. The solid dot, this one is on it, right? The -2 is on it. But ours, it's not that. That would be that one. Ours has no equals bar. It's only greater than -2. So it's not right on it. So the answer is A. Does everybody see that? Let me say that again more carefully. So it basically says, when it says that, that means greater than, not equal to. So it's greater than, not equal to, which means open dot. So when you have the open dot, you're not right on it, right? It's like they've drilled out that hole. It's not right on -2. The right on -2 is missing, huh? Does that make sense? All right. Stop me if you want to talk more about it. All right, so there's number 3. Okay. So see if you can figure out which of those 4, A, B, C, or D, goes with that symbol. So the shading represents the X. Where is the shading? Where is the X? Yeah, so what does this say? Greater. X is greater or equal. Right? Because X is on the wide mouth side again. So X is greater or equal. That means to the right. Right? Greater is to the right. And am I looking for the solid dot? Can it be right on it? Yeah, so it's answer C, isn't it? It's this one. It's right on the 6 and to the right. Does that make sense? It's right on the 6 and to the right. Good. All right. I'll keep moving. You stop. All right. So we have. Well, this one simply is actually, I think, easier. The W is just between them, huh? The W is between the 0 and the 4. Let's write it that way. Between 0 and 4. And does it have the equals bars?
No.
Not equal to. Right? No equals bars. Right? If there were bars here, boom, boom, like that, then that would make solid dots, wouldn't it? So it's the shading that's between the 0 and the 4, but it doesn't hit the ends, right? Because it's not equal to. So which one's that? B. It's this one right here, huh? Make sense? The shading goes between 0 and 4, but it doesn't hit the 2 ends because it's not equal. Can't be right on 0 or 4.
So W is greater than 0, but less than 4.
Exactly. That's what it's saying, huh? Yep. That's right. W is on the wide side of 0. Compared to 0, it's on the wide side. So if you just look at it's greater than 0. And it's on the narrow side of 4, so it's less than 4. So if it's bigger than 0 and less than 4, it's between 0 and 4. That's exactly what that's saying, yeah. Yeah, good. All right. Okay, so we've got that. So that's between again, huh? The X is between -1 and 6. It's between. But there's one side has open dot and the other side has a solid dot, huh? Everybody see that? because it doesn't equal the -1, but it does equal the 6, huh? It's right on the 6. So which answer is right on the 6, but not on the -1? Yeah. Everybody sees B? Shading between 0 and 6, or I mean -1 and 6. But it doesn't hit the -1, right? It's open dot at the -1. Doesn't quite hit there, but it's solid dot at the 6, which is right, because it can equal. X can equal the 6. Let's get the bottom of the equals there. Good? Are these your favorite questions? You're hoping for a lot of these on the exam next Monday? Good? All right. Well, they'll have their fair share. All right. So 6x plus 4 minus 5x less than or equal to 13. So try that one. So 6. Oh, here's the wall. The the equal sign, the greater than. To make that your wall, right? Remember how to. So it's just going to be just like what we did yesterday. So there's the wall, and then 6x minus 5x. Yeah, that's 1x or just x. Is that okay so far? Is that making sense so far? Just like terms there. And now x is saying what x is always saying. I want to be alone. So what do we do to get x alone? Yeah, we're going to add the 4. Or subtract 4, huh? So we always do the opposite. Subtract the 4. That'll get rid of that. And that's 9. Like that. And that's it, we're done. 1x, you don't need to do anything with that 1. By the way, I've seen some students, they'll divide by the 1 or whatever. But remember, what is 1 times x? Just x. Huh? 1 times, you can just erase it. Remember, 1s are invisible, really. 1 times x is just x. So we're done right there. So it's exactly like solving yesterday.
So if you were to go back and take that 9 and plug it in up there, does that work out?
Yeah, it would make it equal.
Because you're subtracting a big number. Okay.
Right, exactly. It doesn't look like it at first. So 6 times 9 is 54. Yeah, we can do it. Let's do it. So we put a 9 in there and a 9 in there. Yeah, 6 times 9 would be 54 plus the 4 minus, and then 5 times 9 would be 45. So, I don't know, I would need a calculator, but 58 minus 45, I guess it's 13. That's the number on the other side. It works. Good on that? So just like solving from yesterday. You don't need to do that little check thing I was doing at the end. All right, so all right, so okay, try that one. Can you solve for x there? So what do you do to solve for x? Yeah, so x is saying I want to be alone, and that 5 is times it because it's right next to it, so it's divide, huh? Yeah. So then that's just 3, huh? Good on that. And then after answering that, they're going to want you to put that on the number line. Can we just do the number line right here? So if I just put down the 3, right, I'll just put the 3 right in the middle. It doesn't matter, where I know 0 is somewhere, whatever. Just put down the 3. So which side, Well, first off, is there gonna be an open dot or a solid dot
Oh,
at that 3? Yeah, it's not equal to, so it's an open dot, huh? It's not right on the 3, it's not solid, right? It can't be right on the 3, it can't equal the 3. And then which side is the shading, the right side or the left side? What does that symbol say? No, it's all about the x. Focus on the x, remember, because the x is the shading. When you shade, you're shading x. So is x over here or is x over there? What does it say x is? X is less. X is on the narrow side of the symbol here, huh? Right? So x is on the narrow side, which means x is less than 3, is what that says, huh? Does that make sense? So where's less than 3? Over here. X is not to the right, x is to the left.
That goes the same way as the arrow.
Well, no. I know that'd be nice, huh? I'd give you that rule if you could. See, they could turn it around. Yeah, Melissa's question's a good one. It's almost that way, but what if they wrote it that way? Think about what that says for a minute. What if our answer came out that way with the x on the right side? What does that say? So you always read these symbols starting with x. It's always about x because x is the shading. So what does that say about the x? X is what? Less. He's on the narrow side. Even there. Does everybody see that? Sometimes students think, well, no, you just look at the symbol, Miss Karen, and that way's always greater, and that way's always less. That's not true. That's not true. It depends who they put on which side. So it's always x. Always take x. I'm not saying this very well. Take x's perspective. There we go. So pretend you're x, right? Wherever x is, right side, left side, whatever. Just go wherever x is and say, okay, x, what is it saying about you? What side of the symbol are you on x? Narrow side. X is less, which means it's saying the same thing that is. But see how that arrow is pointing to the right now and the shading's not to the right. That's why you can't just go by the arrow. You just have to read the symbol. X is less. He's on the narrow side, less is left. That'll work.
If you do it in reverse though, and do 5 times 3, it's not less than 15.
I'm sorry, if you do what's that?
5 times 3.
Oh, right. If you plug in the 3 there, you put the 3 back in, you'll get equal to 15, huh? Yeah, because really, you're not really supposed to plug in 3. What does this say you're supposed to plug in? Things less than 3. So technically, you can't plug in 3. You can only plug in things lower than 3 to make it true. Yeah, you can still plug in 3 and see what it should be equal if they had allowed equal, but they didn't allow equal, did they? So yeah, that's why the answer is not x less than or equal to 3, because you can't equal 3. It's just x lower than 3 on that. Alex?
I was just gonna say, is that why it's called an inequality?
Yeah, right, because it's not equal. It's an inequality. Yep. Right, so minus 2x less than minus 10. All right. What are we supposed to do to get x alone? X is always yelling out, I want to be alone. So what do we do to get x alone? Going to divide, huh? Yeah. And what are we going to divide by? -2, right? Yeah, and we always divide, that's good and correct to say -2. We always divide by the identical twin, don't we? Same sign, same everything. We don't divide by regular 2, in other words, right? Remember we talked about that? When dividing, it's always the identical twin you divide by. Exactly what's next to x, exactly, same sign, same everything, you put under the bar, huh? That's correct, that's right. Now, does anybody know, anybody seen this before? There's some kind of trick you've got to do when you divide by a negative number with a greater than, less than symbol.
You gotta flip.
Got to flip the sign. Have you seen that before? Right then, it makes the sign turn. So let me write a note. When you divide, and I'll say or multiply, but we don't usually multiply, by a negative, you must flip the symbol. So when you divide or multiply by a negative, you must flip the symbol. Okay? So now, the rest is normal. That's the only trick. The rest is normal. So what do I mean normal? What happens on the left side? Well, those negative 2's cancel out and X got his wish. He's alone, the big loner. And now the symbol in the middle is now going this way, huh? And what's the right side? What is negative 10 over negative 2? Yeah, two negatives? Positive 5. We good there? So there's our answer. Good questions on that? So if I was you, maybe I'm just a questioning person, but I would say, why? Why do we flip that symbol? That's weird. Where did that flip the symbol thing come from all of a sudden? When you divide by a negative, you got to flip the symbol, turn it around, move it the other direction? That seems kind of crazy.
Because like negative times negative makes it positive.
Negative times negative is positive. It has something to do with that. Yeah. It has to do with, like always in math, truth, right? There's something true going on there. If you think about it, let me show you an example with negatives. On a number line, here's 0, here's negative 1, here's negative 2, let's say. If I, which one of those is smaller? 0, negative 1, negative, which one's a smaller number technically? If it's your bank account, negative 2 is smaller because you're more in debt, right? Been there, I've lived half my life there. So with 5 kids and always close to debt. So negative 2 is more in debt. So more negative. So it would be true to write like that, wouldn't it? That's the correct true way to write that. Negative 2 is smaller. It's on the narrow side. Right now, watch something interesting. Or anyway, in fact, let me just, well, that's good. We'll just go with that. Well, here, no, I want to change because I don't want you to get confused with something else. So that's true. That was great and true, but let me say something else that's be more helpfully true. So here's 0. Let's do like negative 4 and then negative 8 be way down there. Which one of those is smaller? The negative, this one is less, isn't it? Negative 8. So negative 8 is less than negative 4. Good, that's true, right? So now, watch this. If I divide both sides, say by, I don't know, negative 2. There's no reason. I mean, you might, why do you, but just suppose I just did that. Just divide both sides by negative 2. And don't turn the symbol. I'm going to prove that truth demands you turn the symbol by not turning it and watching how we get something wacko happen. If you don't turn the symbol, what do 2 negatives do? Positive, and 8 divided by 2, 4, positive 4, regular 4. Don't turn the symbol. Now 2 negatives, positive, 4 divided by 2. See what it says now? That's not true. 4 is not less than 2. I did the same thing to both sides, but it was a negative. Do you see? When you divide by a negative, the truth goes the other direction. Now it's right, huh? So it's just truth, like everything else in math. When you divide by a negative, the only way to stay with the truth is to flip the symbol. Flip the symbol when you divide by a negative. All right, we can just see from that example that that's where the truth comes. So 4x minus 4 greater than 16.
Before you move to that, could I ask one more question on the last? I
Uh-huh.
don't think you need to go back, but if you have 2 negatives on both sides, then that's when you have to, I mean, you couldn't do it if one was positive and one was negative. You wouldn't have to flip the sign, right?
Oh, I see what you're saying. Yeah, don't worry. Don't think about it that way.
Okay.
About like are there 2 negatives or just think what did I put under the bar? What did I divide by? So no matter what was up there originally, don't let that concern you. Just ask yourself, what did I put under the bar? If I put under the bar negative, I've got to turn the symbol.
Okay.
Just that straight ahead. Because there could be all different kind of weird looks they can give you in the beginning. You just focus on what did I do? What did I put under the bar? All right, let's try that one. So Same thing, X is saying what he's always saying, I want to be alone. So add 4 to both sides. Bless you. Get to there. 4x is greater than 20. Now how do we finish solving for x there? Divide by the 4. So x is like that. And do I need to turn the symbol? Yeah, no, because what did I put under the bar? A positive number, so that's okay. It's only when you put under the bar a negative number that you need to flip the symbol. Well, that makes sense on that. Could you put that one on the number line? Because I think most of these are going to have you graph them, So just go ahead and put the 5 in the middle, and you decide 2 things. Is it an open dot or a solid dot? And then which side is the shading on?
Open to the right.
So it's an open dot because it's not equal to, so it's not right on it, huh? Yeah, now is the x over here or is the x over there? What does it say? X is greater. X is on the white side, huh? So Jose's right. It's to the right, huh? Like that. Because you're shading where the x is, aren't you? We're always shading where the x is, and that's exactly right. It says x is wide side. X is greater. Greater stuff is to the right. Good. Not too bad of a section. Julio.
Yeah, so open dot, one more time, open dot.
Yeah, open dot, yeah. Open dot means it's not there. So if they had instead, let me come over here and change that problem. If they instead had x greater than or equal to 5, so that means you could be right on the 5. You not only, so they didn't. They didn't have the bar. But what if they did? What if they said, hey, the answer is, what if this was the final answer? X is greater or equal. That's the bottom of an equal sign, So if they said that, then I would also include the 5. So I would put the number line, and when I did the 5, I would do a solid dot, meaning the 5 is part of the answer, because you could be equal to 5. And, of course, shade to the right, because the x is greater. That would be the difference. So if you have the equals, you have a solid dot, because you're right on that spot. If you don't have an equals, you have an open dot, because you're not right on that spot. All right. Let's keep. Okay, let's try that one. 9x plus 15 greater than 6x minus 3. So x is on opposite sides there. What do we always do when x is on opposite sides?
Get rid of one side.
Yeah, exactly. Get rid of one. Usually the lower one, huh? Yeah. So subtract 6x from both sides. That'd be a good plan. Gonzo like that. That good? Subtract 6x from both sides. So 9x minus 6x is 3x. We good to there? And now x is still saying what he's always saying, I won't be alone. So what do we, so here's the wall. X is over here. He's got a 3 with him, which we're going to save to the end, and a 15. So what do we do next? Subtract that 15. You guys know this. All right, subtract that 15 from both sides. These are gone. 3x, and this is minus 18. Did you get that okay? Right, if you lose $3 and you lose $15, you lost $18. Last step to get x alone, divide by 3. So x is, there we go. Does that make sense? Can you put that on the number line? Put the minus 6 right in the middle. So figure out whether you're going to have an open dot or a solid dot, and then if you're going to shade to the right or the left.
Open dot to the right.
Well said. Right, open dot, because it's not equals. And the shading, what does it say about x? X is on the wide side, huh? X is greater, so the x is over here. Greater is to the right, huh? So x is to the right, the shading is to the right. Is easy? Questions? All right, we're getting near the end. All right, so 7 minus 19x less than or equal to 3 minus 12x minus 6x. Okay, here's the wall. X is saying I want to be alone. Got a lot of steps there. What do we do first on this one? Combine like terms. These two are like terms. Yeah, so let x's on the same side. Let them just combine together. So minus 12x and minus 18x, what are they going to make? Minus 18x. Is everybody okay with that, first off? Does that make sense? Minus 12x and minus 18x. I'm sorry, minus 12 and minus 6 makes minus 18. Right, if you lose $12 and you lose $6, you lost $18. Okay, good. Now, and notice how I bring everything down. I really encourage you. These are about kind of being organized, you know. So in other words, don't just write minus 18 and then kind of leave everything else off and then start doing other things. You'll probably get messed up in these because they're going to just keep getting messier and uglier, and you want to keep it all organized. So I just do the one thing, and then I bring everything else down. Okay, next. What do we do next? Really, we should not be thinking about the 3 or the 7 because my focus is the x's, right? See, these guys here are the x terms. They're my focus. So deal with them first off. Now, what do I do to deal with them? What we do when we have x's on opposite sides. What do we always do with x's on opposite sides? Yeah, we have to. You can do plus 18 or plus 19, either one. X. Yeah, you gotta do the opposite of somebody. Remember, when you have x's on opposite sides, do the opposite on both sides. Do the opposite on both sides. So what do I mean? What's the opposite? Yeah, I usually do the lower one. Who's the lower one? You don't have to. You could really get rid of either one of those. Remember, they're both negative. They're both debt. Which one's worse debt? 19. $19 in debt is lower than $18 in debt. The lower one is the minus 19x, technically. So I'm going to I'm going to do the opposite of him. Does that make sense? But whatever I do to one side of the wall, I've got to do to the other side of the wall. Good, and then gonzo. Now you could have done plus 18x, that's okay. It's going to be a little easier though to do the lower one, the opposite of the lower one. And notice how I do it on both sides and I draw a line. Right, are you seeing my style? I mean, and it's not just my style, it's what every math teacher does basically. Because we have what's there and then what we do to it, and here, line and now result. So you have something there, action taken, result. Action taken, result. Action taken, result. Action taken, result. You know, see how it flows and it goes straight down like that? You want to be organized in this because they're getting messier. So you want to just have this, the line, result. Action, line, result. Action, line, result. So these two, what do they make? 1x, or just x, huh? Ones are, you can make that invisible. Bring everything else down. Don't just write it in the side or something like that. That's a plus. It needs a symbol in there. It's a plus 1. And bring down the 7. Good to there. So I brought everything else down. Now x is still saying what he's always saying. I want to be alone. So what do we do to get x alone there? Subtract the 3. And notice how I dealt with the x's first before I dealt with the 3 and the 7. Right? Why? Because I had to find out where x was going to end up. I didn't even know where x was going to end up, so I didn't know which of the ones I wanted to get rid of, 3 or 7. See why it's not a good plan to do the 3 and the 7 early on? Because you don't know where x is going to end up. Always do the x's first. Get them in one location, then turn your attention to the other things. So get rid of the 3 on both sides, gonzo. So then we get 4. 1x is just x. Is that good to there? All right, now how do we put that on the number line? We'll put our number line, put 4 in the middle. Open dot or solid dot? Yeah, we have the equals bar this time, huh? So solid, we're equal to the 4. We include the 4 right on the money. Now, is the x over here on the right side of 4 or over here on the left side of 4? According to this statement, is x bigger than 4 or smaller than 4? What does it say? Remember, you start reading from x's perspective. Don't just go left to right. We don't read those symbols left to right. We start with x, wherever x is. What does it say about x? X is
Greater.
wide side, greater. X is on the wide side, huh? Does that make sense? So students that don't understand these well, they think you always read left to right and it says less. That's just a less than statement. That makes no sense, right? That'd be like if I said, hey, I want to tell you about my 2 friends, John and Mary, and their ages are different by 3. Well, it doesn't tell me which one is bigger, right? You know, it matters who's on which side, right? So the x is on the wide side. X is greater than 4. So x is bigger than 4. So the x is the right side of 4, and not over here. And there's our answer. That was a complex one. How many got that one right? Get that one right? Yeah, I think a little bit less than half. Let's redo another one like that. I'll let you copy that one down. Everybody got that one down? That good? Alex?
If you had actually, instead of adding the plus 19x.
Did the 18?
18
and not the negative x?
Yeah.
Can you do that?
Yeah. Want me to go back and fix that? Then you're going to need to divide by -1. The symbol's going to flip. That's why that one's more tricky. So,
And it was like an extra step.
an extra step. Exactly. That's why it's easier to add do the opposite of the smaller number. But yeah, I'll show that. Right to here, if instead you said, look, I'm going to add 18x to both sides, you can do that. It's going to be a little harder because negative 19 is the smaller one, really. So what are you going to get? That'll be 7 minus 1x there, huh? And that's 3. These cancel. Right now, x is saying what he's always saying, I want to be alone. So what do we do to get x alone now? Now this time we got to get rid of the 7. Yeah. So that'll go. And then we get minus 1x, and that's minus 4 now. 3 minus 7. And now x is not alone this time. It's got a minus 1 with him. So how do you get rid of any number next to x? Last step is always? Divide by -1. That'll get rid of that minus 1 and get x alone, huh? But when you divide by a negative, when you put a negative under the bar, see how I just put a negative under the bar? I divided by a negative. You got to flip that symbol. So x is greater than or equal to now. Two negatives? Positive 4. Same answer in the end. Isn't that beautiful? The way math will result in the same answer as long as you take logical steps. Same exact answer.
Well, even if it said just negative x instead of negative 1, you could still divide by the negative.
Yeah, because a negative x
The hidden 1.
is a hidden one, the invisible one. That's right. You remember, x wants to be totally alone. No negative on it, no nothing, to use bad English. Not anything on it.
Nothing.
Right?
So there will never be a negative x.
Correct. We don't leave it that way. We divide by negative 1. And that flips the symbol. Exactly. Let's do another one. That was. So these two right here are like their x's on the same side, so they get together. They combine. So what are they going to make? Minus 16x? Good so far? So those two combine like terms. Now, x is on opposite sides. So these were x's on the same side. So they just like terms, right? But now x is on opposite sides. What do we do with x's on opposite sides? The opposite of one of them, huh? Yeah, which one is actually lower? Yeah, because they're both negative, they're both debt, right? One of them $17 in debt, and one of them $16 in debt. So get rid of the lower one, which is that, and do the opposite. The opposite in negative 17x is plus 17x, huh? And you gotta do it to both sides. This is gone. So draw your line and bring down the result. And what's the result? Well, just on this side, it's just the 6. On the other side, it's plus 1x. Is that good? To there? All right, and now x is saying I want to be alone. So what do we do to get x alone? Subtract 5 from both sides. And so, do I turn the symbol?
No.
When do I turn the symbol? When I put a negative under a bar, huh? That's just 5 subtracted. It's not divided. So no change in the symbol. There's just 1, and these are gone, so this is just x. Is that good? Now, it's fine if you want to leave it that way, but a lot of times, in fact, look, even on this very question, they're forcing you to put the x on the left side. See how they're doing that? You're going to have to answer. So can I take this symbol, this answer, and turn around the whole thing?
Yes.
Sure. Just turn the whole thing around. It's the same as, and then you just flip the whole thing. See how those are saying the same thing now? How do you know? Well, in both cases, x is on, remember it's all about x, huh? X is on the wide side. X is on the wide side. So it's both saying x is greater or equal to 1. And there it is. Either way. Is that good? So the test tomorrow's the practice test so quickly, and Monday is the real test. It'll be multiple choice. So you might have this, and you might need to check, because A, B, C, D, you need to match the one. So you should know those are the same. If you have this answer and option C is that, grab it. It's the same thing as yours. Good? Comfortable with that? So they get worse, you're telling me, Alex? So parentheses, we're just going to multiply through right away. Let's see what we got here. 6 r minus 7 plus 1 greater than 7 r plus 3 minus 28. There's the wall. All right, go to it. Try that one. So multiply through those parentheses. First off, distribute through those parentheses, right? Okay, feel free to check with those around you. Okay, so distribute. So 6r minus 42 distribute 7r plus 21. Good so far? Like that. Now, so remember, things that are on the same side, they just like terms, just combine together as like terms. So these two and these two, they're on the same side, so they'll just combine as like terms. So we get, what's that, minus 41 and minus 7. See how these two made mine? Just use your calculator. So things on the same side, letters, numbers, whatever, you know, those just add, subtract like terms. Now I'm thinking about the fact that I have r's on opposite sides. Don't worry about the minus 41 and the minus 7 right now. Oh, the final answer is, isn't it r less than negative 34? I think you should have r is less than negative 34. If you've got that answer, you're good. If you don't, you made a mistake somewhere. So check out what I'm doing here. So r's on opposite sides. What do you always do? Now, so that's different than the same side. If those were on the same side, if I had like 7r and 6r on the same side, just boom, 13r. No big deal. Just add them up. But when you have the letters on opposite sides, what do we always do when they're on opposite sides? We get rid of the lower one. We do the opposite of the lower one. So which one's lower? 6r. So the opposite would be minus 6r. So I take that action to both sides and draw my line and show the result. See what I'm doing there? I did the opposite on both sides. So that cancels. And then I have minus 41. This is 1r. 7r minus 6r is 1r. Okay, now r is saying I want to be alone. So what do we do to get him alone? Add the 7. And 1r, no, what is that? Use your calculator, is it minus 34? And there we go. Now that's the right answer. They're going to make you, see up here how they, in the answer box, they make you put r on the left. So here, let me bring that over here. So, well, I'm kind of running out of room, aren't I? Bring it over here. So minus 34, 1r. 1r, you can just erase that 1. It's just r. Now, turn the whole symbol around. The whole statement around. That's the same thing. Is everybody with me on that? You can always grab a symbol and turn the whole thing around. It's the same truth, right? Like if I took 1 less than 2, and I turned the whole thing around, 2 greater than 1. That's still saying the same thing, huh? That's all I'm doing there at the end. Does that make sense? So this is the answer they want. R less than minus 34. Is that good? Everybody seeing those steps? How many got that? Was about half of you, I think? About half got that? Okay. That's good. These take practice, don't they? All of you are just cranking it right through. So distribute. You ready? It's r less than negative 29, right? Isn't it? Isn't that the answer if I'm remembering right? Yeah. Isn't that the answer right there? Yeah. So if you got that, you got it right. Now you might have it written like this. That's the same thing. Those two say the same thing. In both cases, the r is on the narrow side, huh? So they're both right, really. Does that make sense? Right. Both these statements. The r is on the narrow side, so he's less. The r is on the narrow side, so he's less. Those both say r lower than negative 29. So they're both right. If you got either one of those versions of the answer, you are 100% correct. So you're good. If you didn't, let's see where you made a mistake. I'll do the problem now. Multiply through 5r minus 40 plus 2. Distribute 6r plus 18 minus 27. Good so far. Now, remember, stuff that's on the same side, just add, subtract together. So these two and these two, just use my calculator, add, subtract together. What's that? Minus 38. And what's this? Minus 9. for those two. That's good. So those two became -9. These two -38. Now, I've got r's on both sides. What do we always do? Get rid of the lower one. Who's the lower one?
5.
Yeah. So notice, don't do the numbers right now. Don't do 38 and 9. Do the r's. Lower one's 5. Do the opposite. That's what gets rid of it, huh? So draw your line. Show the result of the action. So what's the result? These are gone. This is -38. This is 1r. Good to there. Okay, now r is saying I want to be alone. So what do we do? Add the 9. And we get minus, is that yeah, that's the -29, huh? So like that, or then turn it around, it would go like that, and you turn the whole thing around, right? 1r is just r. You can erase that 1. Good on that. Questions I can answer? Getting more and more comfortable with these things? Try that. Okay, so this is called a compound inequality. Compound, just like they say, a compound fracture or something. It's just big and complex. So it's compound inequality. It's just basically it's got 3 parts. What it is you have 2 lines. You have 3 instead of just a left and a right. You have a left, middle, and right. And your focus though is the x. It's always about the x. Just stay focused on the x, which in this case is in the middle, huh? So don't even worry, don't even look at the 14 and the 26. Just pretend they're not even there. What is X saying? What is X always saying?
He wants to be alone.
I want to be alone. He's the big loner, right? So X wants to be alone. So it's all about the 4 and the 2 then. That's why I'm saying ignore the 14 and the 26. It's not about them. It's about the 4 and the 2. They have to go away so that X can get his wish, which is always his wish, to be alone. So, what do we do first to get X alone? Subtract 2. Remember, you save the number right next to X, the 4, for last and dividing. Oh, we'll do that last. Yeah, so the first thing you do to get X alone is you get rid of the 2. So subtract 2. And you do all 3 of them. See how I'm doing all 3 instead of just left and right, it's left, middle, and right. But you still just keep the balance, huh? You just do it to all 3. That makes sense? Whatever you do to the middle, you do to the right, and you do to the left. You just do to all 3. Draw your line and show the result of that. What happens? The 2's cancel, and we get over here 12, 4x in the middle. Over here, what's that? 24. Good so far? Now, again, the focus is X. Keep your eye on the X there. So X is saying I want to be alone. So what do I do now to get X alone? What is that for? That 4 is right next to the X. No symbol in the middle. So it's times. So what do I do to get rid of a times thing? Divide. Divide by 4. And when I do to the middle, I do to the left and the right also. Divide by 4. All of them. Left, middle, and right. So what do we get here? 3, x, 6. Because the 4's cancel in the middle, and we got it. There's our answer. X is between 3 and 6. So just stay focused on the X in the middle, and just do what it takes to get X alone.
So if there were 5, 6 different inequalities,
Right.
it would still be all across the
Yeah, all across the board. Those would be awful, Alex. They don't give us anything like that. It's a good thing you're not writing a math book. You'd make them awful. Huh?
How would you represent that in the line?
Yeah, remember we did a couple like that? That's between 3 and 6. The X, the shading, is between 3 and 6. Solid dots, yeah. So I get the solid dots, the shading in between 3 and 6. The X is in the middle, between 3 and 6. The shading is between solid dots, because they're both equal. Good, all right. So let's... All right, so it's all about the X, and so our attention is focused Right there, huh? Don't worry about anything else, just right there where X is in the middle. Just focus on that. And X is saying, I want to be alone. And so what do we do to get X alone? Well, we got to get rid of the 2 and the -4. We save the 2, which is right next to the X, for last. You save those will be divided at the end. First, get rid of the -4. So how do we get rid of that -4? Add 4. And whatever we do to 1, we do to all, left, middle, and right, huh? Add 4 cancels out. That good to there? Okay, now, so if you, over here, it's easy to make a small mistake. Just be here, always think money. If you lose, that's -2. If I lose $2 and then gain 4, I've gained 2 overall, huh? Use a calculator also. Over here, that's 14. Good to there so far? And now, what is X saying? I want to be alone. So what do we do to get X alone? Divide by 2. Last step's always divide, and left, middle, and right. Cancels out. Okay, 2 over 2 is 1. And this is 7. And we're done. X is between 1 and 7. On a number line, we would put a 1 with a solid dot. Whoops, that was not a 1, but a 7. Put a 1, put a 7. The X, the shading, is in between 1 and 7 solid dots, because the X is between. Good on that? Comfortable? All right. Okay. Minus 4.5. 2x minus 1.5 is in the middle. And 8.5 on the right. So again, I encourage you to put in the line so we have a left, a middle, and a right. Left, a middle, and a right. So X wants to be alone. All right, so X, it's always about X, huh? Just focus right there, focus on X. X is saying I want to be alone. So what do we do first is we get rid of that 1.5, huh? Do the opposite of that minus 1.5. And whatever we do to one part, we do to all three. Left, middle, and right. Okay, these are gone. And then just use your calculator. This is minus 3. This is 10. You need to think about money. If you want, I'm always doing the money thing. Right? If you lose $4.50 and you gain back $1.50, you're down $3.
It's not equal.
Oh, it's,
Oh, you're right. It's not equal. Yep, thank you. I wanted to make it a different problem. Here we go, thank you. All right, and next, X is saying I want to be alone. Divide. Last step's always divide, and we do all three. And so this would be minus 1.5. 5. There we go. We got it. Good, getting easier. So it's just practice, isn't it? There's a lot of practice until you can do, 7, 8, 9, 10 of these in a row without making a mistake. Just takes practice, practice, practice. Yes, yes. Okay, so it says 7 times a number. So they want me to take these words and turn them into like a greater than, less than kind of symbol. I mean, inequality statement. So here we go. 7 times a number. What do you do with that first off? 7x less 32 minus 32 is at least. Now that's probably the tricky one. What does that mean to say at least? What if I say I've got at least 3 coins in my pocket? 3 or more. Doesn't that mean 3 or more? At least 3, right? 3 or more, so it means greater than or equal to. At least means you got that many or more. You could be equal or you could be more. If you have at least. So 33, is that what it is? Yeah, 30. No, 53, I can't read it. 53. 53. All right, so 7x minus 32 greater than or equal to 53. At least means greater than or equal to.
So 8.
Is that what it is? Yes, then they want you to solve the thing. So let's go ahead and solve it. Just solve that in your head, Alex? I'm impressed. Let's solve that. So what would we do first? X is saying what he's always saying, I want to be alone. So what do we do first to get X alone? You can do that. So go ahead. Oh, you say A. A. I thought you were saying 8. I thought you'd solve the whole thing in your head and you already give me an answer. You're saying A. Yeah, right. Totally A. Totally A. A for apple. You're right. Now, part 2, they're going to want you to actually solve. So can you solve that? Yeah, so answer would be part A so far. That's the first part. And then now they want you to solve for X. What it is? So X is saying, I want to be alone. So what do we do first to get X alone? Going to add 32. Always do the opposite. Those will cancel out. And we'll get 7x, bring down the 7x. What's that? 85. Good to there so far? And now, divide by 7. And what is that one?
It just stays like that.
Oh, you can't. Yeah, it doesn't go in there, does it? It just stays that way. Yeah, if you divide 85 by 7, it's some ugly decimal. So we just leave it.
When you try to put a decimal in there around it, well, it tells you.
It says your fraction. Does it say fraction?
Yeah.
Yeah.
It doesn't say fraction.
Oh. Let's see. So we just keep that fraction and we're done right there. Good. So we finished up that section. That was a big one. So why don't we take a break there? That was the end of 3.5. We're going to come back for 3.6. One more section for today. One more.